Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give another example, which is related to finding the covariance of two linear combinations. In this case, this is the first linear combination, u is equal to x plus 4y plus 2z. And this is the second linear combination, which is v is equal to 3x minus y and minus z. And let me just rewrite that into something that looks like this. Okay, so let's say what we have here is u is 1 times x plus 4y plus 2z. Yeah, so that's the first linear combination. Next we have is v is equal to 3x plus negative 1y plus negative 1z. And by doing this, I just want to explicitly label them as this is a1 x1, this is a2 x2, this is a3 x3. So I'm just following the notation as defined by this formula right here, where the first linear combination has something to do with multiplying and adding the terms of xi and ai and so on. Yeah, okay. Now similarly for the second linear combination, which is this one, I'm going to label it according to what we have right here. So this is actually b1 x1, this is b2 x2, this is b3 x3. Okay, so this is the third random variable that we have. Right, and our job is to find what's the covariance of uv. So what we need to find is what's the covariance of uv. Okay, let me just write down somewhere at the bottom a bit. Okay, we need to find what's covariance of uv, and we know that according to this formula right here, it looks a bit daunting to some of you because it's such a long formula, but don't worry too much about it. We can focus on finding the first part of it, get the result, and then focus on looking at the second part of it, get the result, and add the results together. It is as simple as that. Okay, right. So that's what we're going to do in this video. We're going to start off with focusing on the first part of getting our covariance. So let's start on with finding this one right there. Okay, so this one here. Right, so according to the formula, what we have is I from 1 until 3. So here our n is equal to 3 because we only have 3 random variables. And then we have ai, bi, and then we have variance of xi. And that can be essentially translated as having a1, b1, variance of x1. Okay, I'm just substituting all the i's into this from 1, and then we move on to the next one, which is 2, variance for x2, then plus a3, b3, variance of x3. And from what we have here, which I have changed and labeled as AIs and BIs and XIs, we can see that A1 times with B1 is equal to 3. Just writing down that result straight away. This is variance of X. When you talk about X1, this is correspond to X. And then we have A2 times B2. So this is A2 times B2 is negative 4. And we have variance of Y. And then we have A3 times B3. So A3 times B3 is negative 2, variance of Z. Yeah. And from the information that we have, here is variance of X, variance of Y, variance of Z, and we can just substitute all the values right into what we have here. So we have 3 times 8 plus negative 4 times 12 plus negative 2 times 18. So here is negative 24. Here is negative 36, right? And then we're just going to add them up, minus 24, yeah? Negative, sorry, this is negative 48, this is negative 36. So 48, 36, 84 minus 24, that is equal to negative 60. Okay, so that's the first part. So therefore, we can write down the answer to this one. Therefore, covariance UV is equal to negative 60 for the first part. And we're going to continue doing this process, focusing on the second part. So we're going to do this part now. Okay. And I need space to do that, so I'm just going to erase what I've done right here. Okay. Hang on. Oh, why is it not erased? Okay, something is wrong. Okay, there you go. Okay. Right, now we're going to focus on the second part, which is this one right here. And the formula says that what we have is a double summation where I is less than j. Here we've got ai bj plus aj bi. Notice that you are going to switch the position of I and j on this part right here. Now we have covariance xi xj. Okay, and we're going to start off with a1 because obviously 1 is the lowest value that we have. So here we're going to combine a1 with b2 because j here has to be less than I. Okay, so here, sorry, j has to be greater than I, so 2 has to be greater than 1, and then we are switching that position. So we're going to switch a to b1. Okay, and then we have covariance x1 x2. Next, we're going to consider a1 and we're going to pair that with b3. Again, notice that j has to be greater than 1, so j, this position has to be greater than I. So 3 greater than 1, so we are all right. And then at this part, we're going to switch that to a3 b1. Okay, switch the position and we have covariance x1 x3. Okay, and then we're done with a1 a2 a1 a3, so we're moving on to a1 and sorry, not a1, a2. Okay, moving on to a2 with b3 and switch the position, which is a3 b2. Covariance x2 x3, and we have considered all possible combination of our random variables. We have here x1 and x2, so we're talking about covariance x1 x2. Here is covariance x1 and x3, and this one right here is covariance x2 and x3. Okay, next is a1 times b2. So we got a1 times with b2. Okay, a1 times b2 is negative 1 plus a2 times with b1, so that is 12. And then covariance x1 x2 is corresponding to covariance x and y. Covariance x and y, the result here is 1. So I'm just cutting short the process right here. I'm just going to substitute everything directly. So here is 1. Yeah. Next, plus a1 b3. So a1 b3 is A1 with B3. But let me just A1 and B3, this one. So 1 times negative 1 is negative 1 plus we're going to cross over like this, A3 and B1. So that is 6 plus 6. And then covariance x1, x3 is actually covariance xz. So covariance xz is negative 3. Okay. Then plus A2 and B3. So let me just erase this part. So A2 and B3, okay, A2 crossover with this one, A2 and B3 is negative 4. And then A3 with B2, A3 multiplied with B2 is negative 2. And you're talking about covariance Y and Z, which is equal to 2. Okay. And so if you punch in the numbers here into your calculator, what we have here is this one is 11. So this one is 11. This one is negative 15. Yeah. And this one is negative 12. So here what we have is the result here is going to be negative 16. Okay, it's equal to negative 16. Yeah. Okay, 11, negative 15, negative 12, negative 16. Now we're going to consider the result here, plus negative 16. So final answer to this one is going to be covariance UV is just going to be negative 16. Negative 16 is negative 76. Okay, I think that's all for now. Thank you very much for watching.